Well, we've been talking about a lot of cold air. Also, something that we've noticed, of course, in the wintertime is dry air. So we'll talk a little bit about the science of what we're talking about with dew point, relative humidity, and how that relates to what we do when we heat our homes. So let's first talk about what the dew point is. In the most basic of senses, it's the measure of atmospheric moisture, and you see this expressed as temperature. And it's in a little bit more in depth, it's the temperature at which the air becomes saturated. So we look at our muggy meter. We talk about that a lot in the summertime. When we get those dew points in the 65, 70 range, it becomes uncomfortable. And when it gets to that 70 and above, it's just downright muggy and oppressive. And of course, we talk about those more comfortable dew points in the 50s and even in the 40s. But as we get towards the 40s and below, those dew point temperatures are very dry. That is very dry air. So it is the temperature at which saturation occurs. So when saturation occurs at 15 degrees, you know that it is dry air taking place. Let's just kind of show you what the dew points are. Let's take a random time of Thursday afternoon at 1 o'clock. And you can see dew points are relatively low here at home in the teens. That's with air temperatures around 20. And you can see across the country that those dew points are low. So there's a lot of dry air in place across the entire country. Only in southern Florida, where those dew points are kind of what we expect in the summertime here at home in the 50s, closer to 60, which is, of course, what you expect for southern Florida. So what we talk about when we come into the term relative humidity is that shows how close the air is to saturation. And it's a fraction, or as you know, with fractions, you could also get them as percentages. So in meteorology terms, we usually refer to them as percentages. And these are dependent on moisture and in temperature. You can have 100% relative humidity at any time of the year, not just winter, not just summer. And so these are dependent on those temperatures. So when the air temperature is 70 degrees, that means that at 70-degree dew point, the air becomes saturated. That 70-degree dew point is oppressive, it's humid, and so when you have an overnight in the summertime where the overnight low only gets to 70 and the dew point 70, it's very humid, and it's mostly usually foggy too because that air is mostly saturated. But in the summertime also, you take that 70-degree dew point and make it 90-degree air temperature, the relative humidity is going to go below 100%, but it is still going to be very humid because those dew points are still at 70 degrees. That's that saturation point, which of course is a very humid number. That 70-degree dew point is a very humid number. So that's where the difference between relative humidity and dew point lies. How does that translate to us here in the wintertime when we're talking about our homes? Here's a look at the same time, Thursday afternoon, and we look at the relative humidity values across the country. Extremely low relative humidity values in the desert and in the plains because there is a bigger gap between the air temperature and the dew point. Here at home, it's not quite as big of a gap, so our relative humidity values are in the 60% range. But it is still very dry air because those dew points are in the teens. It's just that the dew point temperature is in the teens, where our air temperature is around 20, so they're relatively close together. So that's why relative humidity values are high. The air is relatively close to saturation. Let's take that and translate that to what we're talking about in terms of heating our homes. When you have air temperatures around 20 and dew point temperatures around 11, that is very dry because those dew point temperatures are low. So that is a higher relative humidity, but it's still dry because we have a low dew point. Now we translate that and we push that air into our homes. We warm up our homes from our heaters, so we have a 68-degree air temperature. The dew point temperature doesn't change, so our relative humidity value is even lower, 10%. So our dry air from outside gets even drier indoors because of those low relative humidity values as we warm up the air. But that gap in the air temperature and the dew point is a lot higher. So that means our relative humidity value is a lot lower. That's where humidifiers and everything else come into play for us when we are heating our homes. But that's very basic on terms of kind of what we're talking about with dew points and saturation and relative humidity and how that affects us here in our home. For Storm Team 27, I'm meteorologist Craig Zapper.